Where's my stylus?
Guys, is Julia here? Are you friends with her? Can you tell her she left here so she doesn't worry about it that I have her? You'll take it for her? Okay.
And then, like, when we took it out, it automatically turned on because of the light.
Find my stylus. Find my stylus, it can't record.
Oh, here it is. Okay.
Yeah. I would like every time. Me too, if I want to see people.
Okay, so we're going to go over an Algebra 2 topic today. We are going to review long division of polynomials and synthetic division. You're going to realize that it's so not bad that last year it seems so much worse than it does this year. Okay, before we do any problems, let's just go over some quick vocab. Whatever is getting divided is called the dividend. Whatever's doing the dividing is the divisor. Your answer that you get after you divide is the quotient. And then if there's any amount left over, we call that the remainder. Perry, AirPods out, please. Thanks. Anybody else? AirPods out. Okay, so you tell me, is 2 a factor of 14? Is 2 a factor of 14? How many people say yes? How many people say no? Okay, 2 is absolutely a factor of 14. Why? Why is 2 a factor of 14? Is it Mike? Michael? Yeah. Okay.
It's because you can multiply.
Michael, could you take out your AirPods, please?
It's because you can multiply it evenly into 14.
Good, because if you take 14 and you divide it by 2, your remainder is what? 0. That means it's going into it evenly. Is 3 a factor of 14? No, because if you take 14 and you divide it, you're ending with a remainder. It doesn't go in evenly. So whenever something is a factor of something else, you can always figure it out by dividing them. And if there's a remainder, a non-zero remainder, it's not a factor. If the remainder is 0, then it is a factor. All right, let's talk about rules for dividing polynomials. Okay, you want to make sure the dividend is in descending order. And you also want to make sure every exponent is accounted for. Okay, let's do a problem. I want us to divide x to the third plus x squared minus 30 by the quantity of x minus 3. Okay, first thing I want to do is I want to look at the dividends. I have x to the third power, I have x to the second power minus 30. Is it in descending order? Descending order means biggest exponent down to our constant. So is it in descending order? Absolutely. But is every exponent accounted for? No, I have a 3, I have a 2, I have a constant. What am I missing? Dylan?
X to the power 1.
Yeah, x to the power 1. So what we're going to do is we're going to change this into x to the third plus x squared plus 0x minus 30. And we'll divide that by the x minus quantity of x minus 3. So now we're going to set up that little third grade house. The dividend is going on the inside, so we have x to the third plus x squared plus 0x minus 30. And on the outside is our divisor, so we are at x minus 3. So now when you're dividing, you are taking the first term. So I'm going to take the x, and now here the x to the third power. And I'm going to ask myself, x times what will give us x to the third? Good. X times x squared. So up here, we're going to put an x squared. And now you take that x squared and you sort of distribute it in to the x minus 3. So x squared times x is x to the third. X squared times negative 3, isn't that a negative 3x squared? And notice how I'm lining it up with its like terms. Now, generally, when we're dividing, once we put a number up here and we multiply it with a divisor, what do we do at this point? We do what with those two numbers? We subtract them. But now I'm not just subtracting a monomial, I'm subtracting a binomial. So that negative has to get distributed in. So I'm going to subtract the x to the third, but then I also have to distribute the negative to the negative 3x squared. So what does that become? A positive 3x squared. So we want to essentially just change all the signs when it comes to subtracting. And when we do that, the x to the thirds will cancel. And then I'm going to have a 1x squared plus a 3x squared, which is going to give us 4x squared. I'm going to bring down the rest of that dividend, bring it all down. So now we're going to do that same process all over again. I'm going to take the x and I'm going to look down here now in my blue. I'm going to say, well, x times what will give me 4x squared? 4x. So on top of here, on top of our division, we're going to write plus 4x. Now that 4x is going to distribute into the divisor. So 4x times x is going to be a 4x squared. 4x times negative 3 is going to be a negative 12x. Because we have to subtract, what do I have to do to all the signs? Change them. We're going to make them the opposite. So it becomes a negative 4x squared and a positive 12x. The 4x squareds will cancel. 0x plus 12x is a 12x. And then I bring down that minus 30. All right, one more time. X times what will give us 12x? X times 12 will give us a 12x. So I'm going to write plus 12. And then now you distribute in that 12 to the x minus 3. 12 times x is 12x. 12 times a negative 3 is a negative 36. Because we have to subtract, we have to change all the signs. The 12x's cancel, and I'm left with a negative 30 plus 36, which leaves us with a 6. Is there anything times x that will get us 6? No. So up here, this is our quotient, and what is 6? Our remainder. And on the test, you'll see it written like this, Q and R, meaning your quotient, which is x squared plus 4x plus 12, and then your remainder, which is 6. So you all tell me, is x minus 3 a factor of x to the third plus x squared minus 30? No. Good. Why no? Because it has a remainder. It has a non-zero remainder, so it is not a factor. Okay, I want you guys to try this one on your own. So my question is, the quantity of 2x minus 4, a factor of 10x cubed minus 34x plus 4. Show your work and explain. So you're trying that on your own. If you need help, raise your hand. I'll come help you. Nikki, what's your name? Vincent? Matisse, did you take my test? Yeah. You did? Why did I think you were absent? Okay. Should you have put a 0 in for something? Yeah, you should have put a 0 in for x squared. So we should have gotten 10x to the third plus 0x squared minus 34x plus 4 on the inside, and then 2x minus 4 on the outside. Who still needs another minute to finish up? All right, somebody tell me what is an answer you got. I'm not going to tell if you're right or wrong. Let's see as many answers as we can get. Dylan, what'd you get?
Quotient of 5x squared plus 10x plus 3 with a remainder of 16.
And what'd you say your remainder was? Did anybody get anything different? How many people got this? Good job. You all win. Good. So this is our quotient. That is the remainder. Does anybody want to see me do it? All right. Is it a factor? Yes or no? How many people said no? Good. Why? Why is it not a factor? Yeah. Excellent. There's no remainder. All right. Let's keep going. I mean, there's a non-zero remainder. There we go. So let's go through now synthetic division. All right, so first I'm going to list out when we use synthetic division. So we're going to say use when dividing a polynomial by a binomial. And I'm going to put a big star here. The degree of the divisor must be 1. So this is very specific. You cannot use synthetic division anytime you're dividing. The divisor has to be a binomial. The exponent on the x, or the variable on that divisor, has to be 1. If it's bigger than 1, we cannot use synthetic division. Right. In addition to that, we want to make the divisor in the form of 1x minus a. So key things here. We want the coefficient on x to be 1, and we want there to be a minus between the variable and the constant term. Right. Similar to dividing, the dividend should have every exponent accounted for. Also, the dividend should be in descending order. And lastly, your quotient will be 1 degree less than your dividend. Okay, I will give you a minute to catch up and write all this out. Does anybody need me to go back up to 1? Okay. Okay, let's do a problem. So we want to use synthetic division to divide the quantity of x cubed plus x squared minus 4x minus 4 by x minus 3. We need to make sure of a couple of things. The most important thing is really all relating to the divisor. The degree on the divisor should be 1, meaning the exponent on the variable should be 1. Are we okay with that? Yeah. We also want to make sure there's no leading coefficient. There's no number that's not 1, obviously, in front of that x. We're good with that. And now also we want it to be x minus 3. We want it to be, the variable minus the constant. Does this fit the format? Absolutely, it fits the format. Now let's go to the dividend. For the dividend, we need it in descending order, check. We need every exponent accounted for. I have a 3, I have a 2, I have a 1, I have my constant. Everything is in tip-top shape for us. So now what we're going to do is we are going to list out all the coefficients for the dividend. So I'm going to list out not the variables, just the coefficients. So I have a 1, then a negative 1, then a negative 4, then another negative 4. Only the numbers in front with their signs. Then what you're going to do is you're pretty much, do you see how this is an x minus 3? If you were to sort of solve this x minus 3, solve for x, wouldn't that be x equals positive 3? It's always the opposite of the number in there, right? So you're going to put whatever that is, if you were to have solved it, inside a box, just like that. So we're not putting negative 3, we're putting positive 3. It essentially ends up being the opposite of the sign inside the parentheses. That's what it always is. Now, for the synthetic division, what you're going to do is you're going to bring that first number down. And then you're going to take the number that you brought down and you're going to multiply it by the number in the box. So 1 times 3 is 3. And now you add the column. So you put it in the second column. 1 plus 3 is 4. We are going to repeat this process again. 4 times 3 is 12. And now we add the column. Negative 4 plus 12 is 8. 8 times 3 is 24. Negative 4 plus 24 is a positive 20. The number in the last column, this is your remainder. So, what is our remainder of this? 20. So is it a factor? No, it's definitely not a factor. Now, we still have 3 other numbers here. We know that last number is our remainder. These other numbers, these represent the coefficients of our quotient. And our quotient will be 1 degree less than the dividend. So my highest exponent in my dividend was x to the 3rd power. So for my quotient, I'm going 1 less than that. So it's going to start off with x to the 2nd power. So this is going to be 1x squared, or just x squared, plus, since it's a positive, 4x plus 8. This is our quotient. Do I need that 1 in front of the x squared? No. And our remainder is 20. Okay, you guys try one. Ready? I want you to use synthetic division to divide x cubed minus 2x plus 6 by x plus 2.
For the second one, does that be minus?
So can we make that a minus? Yeah, it does. So we can make it a minus into x minus -2, right? So we can manipulate that. Or we can just look at it like I had said before. If you just take this parenthesis and set it equal to 0, it would just be x equals -2. So it would still work. All right, who has a quotient for me? What's your name? Kate?
X squared minus 2x plus 2.
X squared minus 2x plus 2. Is that what you said? And then you said your remainder is 2. Did anybody get anything different? How many people got this? Got it? Okay, you win. All right, is it a factor? No, it's not a factor. All right, I'm going to have you try one more. Use synthetic division. Use synthetic division. Okay, what did we get?
Is it 2x squared plus x minus 4?
2x squared plus x minus 4. I got the same. Any remainder? No. So what is this telling us? What conclusion can we make here? It is a factor. X minus 4 is a factor. So there is something times x minus 4 that will give us 2x to the third minus 7x squared minus 8x plus 16. All right, so that brings us to something called the factor theorem. And the factor theorem tells us if we have some function p of x and it is divided by the quantity of x minus a and the remainder is equal to 0, then we can conclude a whole bunch of things. The first thing we can conclude is that x minus a is a factor of p of x. We can conclude that x minus a is, not x minus a, p of x. P of x is divisible by the quantity of x minus a. So meaning divisible just means it goes in evenly. All right, some new things. A is an x-intercept of the graph of P of X. So that means whatever that A value is, that means our graph will cross that number on the x-axis. That's what it means when it says it's an x-intercept. Right? And there's other words for that. If it's an x-intercept, does anybody know another word for an x-intercept of a graph? It's called, starts with a Z, a zero, good Dylan. So we can say A is a zero of P of X. And the last version of basically saying the same thing and saying it's an intercept, saying it's a zero, is calling it a root. A is a root of P of X. So P of X equals 0. Okay, next thing is called the remainder theorem. And the remainder theorem is going to tell us if a polynomial P of X is divided by the quantity of x minus a, the remainder is equal to P of A. I'll explain this because this is a big deal. If a polynomial P of X is divided by the quantity of x minus a, the remainder is equal to P of A. Write it down and I'll explain it. Okay, I want to go back to a problem we did. So let's say I told you if x cubed minus 2x plus 6 is divided by x plus 2, what is the remainder? Okay, well, we already did this problem. And we figured out the remainder is 2. But I don't want to use synthetic division. Based on the remainder theorem, it is telling us that if I basically take my binomial and I solve for x, so if I take x plus 2 and I solve for x plus 2 equals 0, what is x? X is negative 2. If I take that value, negative 2, and I plug it in to the polynomial here, and I simplify that down. So I'm going to take x cubed minus 2x plus 6, and now I'm going to sub in the negative 2. So we are negative 2 cubed minus 2 times negative 2 plus 6. Whatever we simplify down to, that is the remainder, which is pretty cool. So negative 2 to the third power, isn't that negative 8? Then we're going to have a negative 8, and then a negative 2 times a negative 2 is a positive 4, and then a positive 6. Negative 8 plus 4 is a negative 2. Negative 4. Negative 4 plus 6 is a 2. When we did this problem on our own, didn't we figure out the remainder to be 2? So this is what the remainder theorem tells us. How can this help us? Let me show you. Anybody still copying this? You're good? Okay. So why is this remainder theorem helpful? Let's say I ask you, is x plus 1 a factor of x to the 99th power plus 5? Before the remainder theorem, how did we know if something was a factor? We had to do what? Divide it. We had to divide it. And if the remainder was 0, then it was a factor. If the remainder was not 0, then it was not a factor. This would not be fun, trying to divide this, because I would have to represent every power from 99 all the way down to 1. Not fun. But the remainder theorem is telling us, okay, we'll take this, solve for x, and plug it in. If you simplify that down, that tells you what the remainder is. So let's do that. Let's take this, x plus 1 equals 0, x will equal -1. Now let's plug in. So we're going to say -1 to the 99th power plus 5. Whenever you raise a number to an odd power, whenever you raise a negative number to an odd power, is it positive or negative? Negative. Anytime you raise a negative number to an even power, what is it? Positive. So I'm taking -1 and I'm raising it to an odd power, so it's going to remain -1. -1 plus 5 is 4. So our remainder is 4. So is it a factor? No. Why no? The remainder is not 0. There is a non-zero remainder. All right, last problem for today. Okay. Perry, you good? Okay, last problem. So I want us to find k so that p of x equals x to the third minus 2x squared plus 3x plus k is divisible by the quantity of x minus 2. I'm going to do this two different ways. I'm going to do this using the remainder theorem, and I'm also going to do this using synthetic division. So the first one, let's talk about this. If it's divisible, it means it goes in evenly, right? So if it's divisible, my remainder must be 0. So what I'm going to do is I'm going to use the remainder theorem. I'm going to take x minus 2 equals 0, so therefore x has to equal 2. And I'm going to plug it in to p of x. So I'm essentially finding p of 2. And when I plug in p of 2, I'm going to get 2 to the third power minus 2 times 2 to the second power plus 3 times 2 plus k. So now let's simplify this down. I'm going to get 8 minus 2 times 4 plus 6 plus k. Keep going. We get 8 minus 8 plus 6 plus k. The 8 minus 8s cancel. So now I'm left with 6 plus k. Do we all agree this would represent our remainder? Okay, but what do we want our remainder to be? We need our remainder to be 0. Why do we want our remainder to be 0? So it's a factor, exactly. So now, let's write this down, need remainder to be 0. So we're going to take our remainder, 6 plus k, and set it equal to 0. When will our remainder equal 0? When k is equal to -6. All right, I'm going to show you how we could have done this exact problem using synthetic division, and then we'll be done. So doing the same problem using synthetic division, we have a 1, a -2, and a 3, 3, 2, 1, and k. What number am I putting in the box? Nope. 2, exactly. Remember, there was the problem. We're going to put 2 in the box. Bring down that 1. 1 times 2 is 2. -2 plus 2 is 0. 0 times 2 is 0. 3 plus 0 is 3. 3 times 2 is 6. K plus 6 is k plus 6. Do we all agree this is our remainder? That last column. But what do we know? We need our remainder to equal 0. So once again, we get k is equal to -6. All right, we are done for today.